This is a neutralization reaction. I can tell because I have an acid. It starts with H for hydrogen, and I have a base, a hydroxide. But remember, we just count this or work this as a double replacement reaction, and when we do that, the hydrogen, it has a +1 ion, and the fluoride is -1 from the periodic table. Calcium on the periodic table is +2. Hydroxide from our memorized polyatomic ions is -1. So when we come up with our products, we're going to put, I always start with the salt, so I'm going to put the calcium here, and calcium's going to go with fluoride. I better check their charges though. Calcium is in the +2 column. Remember that the charges don't change during a double replacement reaction, so I can just bring these over. And then I see that this is not a neutral compound. I need to correct this formula to make it neutral, which means I need a 2 there. Okay, and now I'm ready to write my other product. Remember, what we're doing is we're taking the front part of one and putting it with the back part of the other. So my other product is HOH, which is just water, but we can treat it like it's ionic just for convenience. Okay, and then our state symbols, well, water will be L, and the calcium fluoride, I was told that the salt product is water soluble. This is my salt. Remember, the salt is the ionic compound, a metal and a non-metal. And since it's water soluble, that means its state symbol is AQ. Okay, one other thing we might want to do to this before we move on is to make sure that it's balanced. So just spot something that is not balanced. And by the way, when I check this, I'm going to count the water as hydrogen ions and hydroxide ions. In fact, I'm going to start with the hydroxide ions because I see they're not balanced. So I'll put a 2 here. That gives me 2 hydrogen ions, so I need a 2 there. That gives me 2 fluoride ions, and here I have 2, 1 calcium, 1 calcium. It looks balanced. Okay, next step, we're going to write the complete ionic equation, and that means I'm going to break apart into ions anything that's a strong electrolyte. So let's just start at the beginning. HF, is that a strong electrolyte? Well, it is an acid, but it's not one of our 7 strong acids. So I'm going to leave that intact. Okay, next we have our calcium hydroxide. Well, that is one of our strong bases, but also it says AQ here. So I'm going to break that apart. Remember to watch these subscripts to get the correct number. We have a way to check that though, and this is okay. And then calcium fluoride, of course, this is water soluble. Ionic compound that's water soluble is always ionized, so we break it apart. And then water is a covalent compound, so we don't break it apart. And I'm going to go ahead and write it the real way now that I have that balanced. And it's okay if you write HOH, doesn't matter. So at this point, I always check and make sure it's still balanced. And that would help me, you know, if I forgot one of those to account for one of these subscripts, like the 2 fluorides, I need the 2 in front here. Next, I'm going to look for my spectator ions, and the spectator ions are anything that are the same before or after the arrow. I see that calcium does not change. What else? Usually we have 2 different spectator ions, but in this case we don't. So our spectators, it's just calcium. And so now we go to our net ionic equation, and we just leave out that spectator ion. And then that might look kind of funny, so we should reduce that. It's not proper to leave these 2's here. In other words, a 2 to 2 to 2 to 2 ratio is the same as 1 to 1 and so on. So I'm going to rewrite that. And there we have it. This is our net ionic equation.